So we are going to be plotting graph of t square against h. So if you have not seen the experiment, you can check the previous video to see the experiment, and this is the readings for the experiment. So if you see plot t square against h, it simply means plot t square on the vertical and plot h on the horizontal. Plot h on the horizontal. So this is a graph. Okay, so here is the vertical, and this down one, ground level, is called the horizontal. So it means that we have our t square on this side, and then we have our h on this side. So the first thing you would do is to plot your vertical lines. So we're going to be plotting the vertical lines like this. You have to use pencil, so I'm using biro because of this video so that it can be visible. Okay, so I'm using biro because I want it to be visible. Okay, so you put an arrowhead on this side, you put an arrowhead on this side, then you label appropriately. So we have t square on this side in second squared, and then we have h in centimeter. Okay, so now the next thing we will do is to check our readings. So if you check at t square, the highest value we have is approximately 9. The lowest value is what? 4. Okay, this is for the horizontal. So you come back to your graph and check. Look at it. You see this big, please bring it down a little bit. I want you to see this box very well. Bring it down a little bit. Bring it down, bring it down, bring it down. So you see this box, this big box, this is 2 centimeters. Each of these big box you are seeing is 2 centimeters. All right, now we have our highest to be 9. You just have to play around numbers until you have something reasonable. That's why it's called reasonable scale. Okay, something reasonable. It's not fixed. You have to use a reasonable scale for your reading. So we have the highest to be 9. So let's run with 1 first. So if you do 1, 2, 3, 4, 5, 6, 7, 8, 9, I think this is cool. So we're going to be using 2 centimeters for what? 1 unit. So we are going to do it like this now. 1, 2, 3, 3, 4,